Okay, this class is an introductory class concerning environmental science. And what we're going to do today is look at the syllabus. This syllabus is available online and everyone should download it. It's very important when you're going over material to have a syllabus with you. So, what are the objectives of today's class? Uh, well, students should be aware of the structure and expectations of the CXC towards environmental science. Be aware of the expectations towards the IA component of the subject. Be aware of the structure of the examination papers and know what to expect in relation to classes for the coming year. So all classes will be through a slide presentation and will be accompanied by a YouTube presentation. So that if you miss a class, the YouTube presentation covers more or less what we cover in class time. And we need to look at the structure of the environment of CAPE subjects. And you know, CAPE is divided into Unit 1 and Unit 2. And the name of Unit 1 is Ecology, Human Population, and Natural Resources. And like all CAPE subjects, it's divided into 3 modules. Module 1 is Fundamental Ecological Principles. Module 2, Human Population and the Environment. And Module 3, Sustainable Use of Natural Resources. For Unit 1, I will do Module 1 and Module 2. And Mr. Banton will do Module 3. Mr. Banton has a double 2-hour class on a Friday, and I have a single hour on Tuesday. No, a double hour on Tuesday, and a single hour on a Wednesday. So, what are the aims of the syllabus? Well, the syllabus has several aims. To stimulate an interest in the environment. Uh, so whenever we're looking at topics, part of the idea is to stimulate an interest in the environment, developing an understanding of the interdisciplinary and holistic nature of the environment. When we do environmental science, we'll be aware that we're doing a bit of chemistry, a bit of biology, a bit of sociology, and a wide range of different subjects. So it's a what you call a multi-disciplinary subject, but the emphasis is different. Um, so although we do chemistry, we're doing it from a point of view of environmental science, and basically that means we accept what chemists tell us, or we accept what biologists tell us, without having to go into the details. So in effect, the principles only have to be looked at a superficial level, but the integration of those principles becomes a more important part of it. So, develop knowledge and understanding of environmental issues and principles, and the ability to apply these, particularly in the Caribbean context. As far as possible, we're going to give Caribbean examples and look at it from a Caribbean perspective, although sometimes we're going to look at it from a world's perspective as well. But if the world perspective gives a better examples and so on. But basically, going to try and keep it as a Caribbean point of view. Develop the ability to identify critical research questions and formulate hypotheses or guiding statements. Develop the ability to collate, analyze and interpret environmental data. Develop the ability to communicate environmental information and ideas logically and concisely in a variety of forms. Things such as this will come through the project that we do. Provide an understanding of the interactions between people and the environment. Increase an awareness of the importance in living in harmony with the environment. Notice this is put in italics because this is really important, that we try to live in harmony with the environment. Lifestyles these days are not in harmony with the environment, and in the end it's going to be to our own detriment. Recognize and evaluate socio-economic, political and ethical issues in environmental science. Foster positive attitudes, values and commitment to identify, solving and preventing environmental problems. Develop an understanding of how natural resources and the environment affect the quality of life and the quest for sustainable development in the Caribbean. This is an important thing, the idea of sustainable development. Quite often the development we carry out is not sustainable, and in the long term the damage done will mean that we can't continue doing what we're doing. So then, an outline of the assessment. Basically we have external assessment, which is out of 70%. Notice this is different, therefore, from subjects such as chemistry, biology and physics, where the external is 80. It's only 70 for in environmental science, which means the IA is worth 10% more. It's 30%. So paper 1 consists of 45 compulsory multiple choice items, 15 on each module. This is worth 30%. And the paper 2, the six compulsory questions, is worth 40%. As I said, the internal assessment is worth 30%. More on that in a minute. So paper 1, as I said, consists of 45 multiple choice items, 15 from each module, and knowledge of the entire syllabus is required. And the intention of this paper is to test candidates' knowledge across the breadth of the syllabus. The point about multiple choice questions is we can cover the whole of the syllabus. When it comes to the structured questions, we can't quite cover all of the syllabus, but the multiple choice can. And therefore, for the multiple choice, you need to know all of the syllabus. You need to know all of the syllabus anyway, because all questions are compulsory. And questions may be based on diagrams, data, graphs, photographs, or prose. So a question might just have written information, or it might have diagrams, data, graphs, and so on. Later on, we'll look at some multiple choice questions. And then Mark allocation. 1 mark will be assigned for each item, and the maximum mark is 45. And this contributes 30% towards the total assessment. And the marks will be awarded for knowledge and comprehension, application of knowledge, and practical abilities. Use of calculators are allowed, and geometry sets are certainly going to be used in the paper too. So the internal assessment is compulsory, and the skills stated here are going to be assessed. Notice, sorry, this is internal assessment. Notice you need to collect data and so on, and development of appropriate models as possible for specific environmental problems. Later on, we will go into the internal assessment in more detail. That's once classes have started and carrying out site visits will become possible. And the journal, this is where we're going to have our site visits, our practicals, and the laboratory exercises, and then the final report based on those. While you're doing that, I will provide feedback and so on. It's important we do this carefully. And this is how a site visit is to be set up. You have an entry number, date, site, objectives, activities, observations, comments, and follow-up activities. So this is how you will write headings for site visits. And then for the practicals, these will follow this sequence here. There's going to be a P&D component. There's going to be an OR component, manipulation and measurement. The planning and designing will be a separate. And the teacher is required to mark and award a score of a maximum of 20 marks for each laboratory report, and then scale to 10. So notice marked out of 20, and then scale down to 10. So the planning and designing is only worth 4 marks, and we're going to do 4 of them. So they're not worth as much as for chemistry or biology, and therefore it's remarked slightly easier for this one. And this gives a structure of the final report. It's probably best if you look at this in your own time. And this is how that is to be marked. So it gives all the things for the final report up to a mark out of 40. It'll become more meaningful after we start doing practicals. So that basically finishes this covering.